Good morning, Year 10. So today's lesson is going to be on the applications part of the exercise from Caboodle. So if you can log into Caboodle and get ready to do some of the questions, that would be great. I'm also doing the 2 examples from that page as well. So you can work through those or just watch me go through them as well on here. So title, date and there's no learning objective today, but that's okay. I've just got a little recap of everything that we've kind of learnt so far in chapter 15. So you can have a read through there, just check that you're confident with all of those kind of concepts there. Obviously the most recent one that we did was the volume of a prism. So finding the area of the cross section multiplied by the length. Okay, so that's the most recent one that we did on Tuesday. Okay, so your first example is coming up. Remember, pause the video at any point just to make a little copy down of the example or a little sketch or a drawing. It's absolutely fine. So a cube has a surface area of 150 centimetres squared. Find the volume of the cube. So that means we've got to find the dimensions of the cube from its surface area. Now we know that for the surface area of a cube, you would have to multiply this by this to get the area of one face, and then multiply it by 6 to get the area of all the faces together combined. So what we're going to have to do is going to kind of work backwards, and we know that these are going to be the same. So whatever happens here, this was squared to find the area of one face, and then we multiplied it by 6. So on the way back of 150, we're going to have to do the inverse. We're going to have to do 150 centimetres squared divided by 6 to find the area of one face. And then after that, we're going to have to square root to find the dimensions, okay? So we'll do 150 divided by 6, which gives us 25 centimetres squared. So one face is 25 centimetres squared is what that means. So what does that mean that the length is going to be? Well, if we square root 25, we're going to get a length of 5 centimetres. So the lengths, that's 5 across there, that's 5 up there, and that's 5 there, because we know that they've all got to be the same, don't they? So the square root of 25 is 5, and so your length of the cube is going to be 5 centimetres. Now it wants us to find the volume of a cube, so all we actually have to do for the volume of a cube is we have to cube 5 centimetres. So your volume is going to be 5 cubed, which is 125 centimetres cubed. Now if you're not sure why we just have to cube it, well, if we think about finding the area of the cross section, well, that would be 5 times 5. And then if we have to multiply it by the length, that would be times 5 again, wouldn't it? So that really is the same as 5 cubed. Okay, so that's where that comes from. And 125 centimetres cubed is your answer there. Now they can ask you to find the other way round. They can ask you to find the surface area from the volume. And that would just be a case of cube rooting to find what a length is, and then you can find the surface area from there. Okay, again, I'm sorry about the working out being so messy, not up to my usual standard, but again, I'm using my finger on a tiny little screen, so you'll have to bear with me. Okay, remember to pause the video at any point if you need to just copy anything down. And here's our second example. So a 3D solid has this net. I'm sure you can see straight away that it's a triangular prism, so actually a right angle triangular prism here. And it says find the volume of the solid. So we've got to find the volume from this net here. Now what we can do is we can kind of think about it, and we can kind of try and visualise what it would look like in a 3D kind of sketch. Now I'm going to try and be neater and use the straight lines. So I'm going to use the diagonal face of 5 there for my first bit, and then I'm going to use the base of the triangle there, which is 3, and then I'm going to use the height of the triangle there, which is 4. Okay, I'm again gonna do some lines. Like that. And we can kind of get a sense. I'm going to use some dotted lines, I think, to show the edges that you can't see. I don't know, is that any good? I think that's good. Okay, so that's kind of what I would think it would look like. And now what I'm going to do is I'm just going to kind of fill in the dimensions. I'm going to type them because I can't stand the look of my handwriting on this. So your height of your triangle is 4. Your base is 3. And your diagonal side there, which I don't think is actually necessary. I think they've thrown that in as a little bit of a red herring there. And then your length of it is 8 centimetres. So the 4 actually belongs to this here, and then your 8 is the length the whole way along. Okay, so there's kind of a view of what I think it would look like as 3D. So now we can kind of see a good sketch of what it looks like. Now we can, I think it's better to kind of do it this way, just so you can see a kind of visualization of what you have to multiply together, because otherwise you might involve that 5, and you do not want that 5, because remember the area of a triangle is base times height, and it's the perpendicular height that you want, so the one with the right angle there. So you want 3 and 4 really are your lengths you want. So let's find the area of the cross section. So the area of the triangle. Now lots of you forgot to, not lots of you, a few of you forgot to divide your triangles by 2 for your volume work the other day. Tut, tut, tut. Very, very bad. Mustn't forget that you need to do 3 times 4 and then divide by 2 afterwards. Okay? Because otherwise you're just finding the area of a rectangle, aren't you, if you don't divide it by 2. 3 times 4 is 12, divided by 2 is 6 centimetres squared. So the area of the cross section is 6 centimetres squared, and then the volume therefore would just be 6 times by 8, using that length there, which would be 48 centimetres cubed. Okay, so that's all you'd need to do, but I always think I like to draw myself a little 3D shape just to kind of get an idea of what the shape's going to look like. You should know to use these two to find your area of the triangle because they have the right angle between them. Okay, you should not use this one because that does not have a perpendicular line to it that you need for the triangle. Okay, so I've selected a few questions from exercise 15.1a for you to do. I've selected how many questions? 5 questions, and then there's an extension question on the next page for you to do. So the first 2 are the same as example number 1 when you're finding the volumes from the surface areas or the surface areas from the volumes of cubes. Now I think you can only do it with cubes in this case when you're given no dimensions, as long as you're given like one of the surface areas or one of the volumes. You can't really do it with any other prism or anything like that, so it would mostly be cubes if they ask you to do it with any sort of prisms. They'd have to give you more information if they wanted you to do it with a cuboid or a triangular prism, etc. And then number 6, a cuboid has a volume of 200 centimetres cubed. Write down 3 possible dimensions. So what 3 things could you multiply together to make 200 centimetres cubed? Number 7, draw and label a sketch of a triangular prism with a volume of 120 centimetres cubed. So you've got to kind of come up with your own dimensions for that. Remember to divide your triangle by 2, everybody. And then number 8, a 3D solid has this net. Find the volume of the solid. So this is a similar question to example number 2. You kind of got to visualise it 3D and then think about which dimensions you need to multiply together, okay, to find the volume. Now your extension question is a real good one. Harriet says that you can use this formula to find the surface area of a prism. The surface area is 2a plus PL, where A is the area of the cross section P is the perimeter of the cross-section, and L is the length. Explain why Harriet's formula works. So that's your extension question today, and I'm very interested to see some of your responses to the extension question. It's a lot of kind of just thinking about that formula. How does it work? Why are those two things multiplied together? So 2 times the area of the cross-section plus something, so find the surface area of a prism. So it's very, very important that you kind of have a go at that, because this is a real good extension thinking question. Now, here are your instructions for what to do. Please submit a clear picture of your work to the Google Classroom. I think that's working best. Some people have said that, or one person has said that every time they try and email me a bit of their work, it doesn't actually get to me. I don't know what's happening, whether they're using a dud email address or something like that, I don't know. But the best thing, if you can, is to submit it via Google Classroom, and then I can just, comment on your own personal page and talk to you about your work there. If you don't know how to do that and the email's working for you fine, then carry on. Why not? Just a few words about your exams from last week. Thank you. I've got a response from all of you, actually, in one way or another, which is great. I have marked all of them. So the set 2 are doing the test today, and Mrs. Hickey is going to mark it for Monday. I'm going to give you feedback on Monday from it. Okay, so I'm going to let you know what kind of you got out of 50. Obviously, if you want a percentage, just multiply your mark by 2 to get a percentage for yourself. Just know that this was more an exercise for you to kind of see how well your revision had gone, what you kind of understood, some topics for you to work on, because all these topics that actually this test was on were so important, especially all that algebra. You're going to be asked to do algebra coming out of your ears, I promise. So, algebra, all that work with algebraic fractions, simultaneous equations, all that, good stuff. That's going to be so important. So if we find out that you're not so strong at it now, that's a good thing, because then you can go back and really, really work on it. So just bear it in mind. The test was an exercise for growth, not to bring you down. Okay, don't think of it as anything like that. So I have copied the answers from Caboodle for the exercise on the next page, so you can use that if you want to, rather than flicking all the way through Caboodle online to find the answers. Please make sure you mark it as well before you submit a picture to me, because otherwise I have to spend a little bit of time kind of checking your answers when I've actually given you the answers to mark. So please make sure you've marked your work before you send me a picture, just so I know that you can see where you've gone wrong and you corrected anything, and you haven't just done a piece of work, sent it to me, and you don't know whether you've got it right or not, because that's not helpful at all, is it? Okay. So once you've done your maths today and whatever other work you've got, have a lovely long weekend. And I hope some of you are doing something fun for VE Day. We're having a tea party in the garden, which would be nice, with all my family on Zoom. But apparently we've got to do some sort of performance, which I'm not excited about. Anyway, I digress. Again, have a lovely long weekend, and I shall speak to you on Monday.